Hey everybody, welcome back. As usual, I'm your field guide, Heather, and today it's time for another featured formation. Today we're talking about the Oracle Granite. It's pretty hot out here today in Arizona, but I trudged up the mountain so I could show you guys, and here it is. Now, you can find the Oracle Granite in southern Arizona and places around Tucson, Mammoth, and Oracle, like its name. As the story goes, a prospector was coming out in search of none other than silver and gold, and when he opened his first mine, Mr. Weldon, the prospector, named his mine after a ship he'd been on, the Oracle. Now, while the Oracle Granite might not necessarily be prophetic, it is porphyritic, and that tells us something interesting about the past. The Oracle Granite is considered a porphyritic biotite granite. Porphyritic means that it has very large crystals or phenocrysts in an otherwise fine matrix or background, also known as the ground mass. Here's an example of that right here. This is a piece of the Oracle Granite that I broke off. As you can see, you see these very large crystals in some relatively finer but still pretty coarse background matrix. The background ground mass or matrix consists of relatively even-sized grains, while those phenocrysts are huge. But how do these crystals get so big, and why aren't they always big in every rock we find? Well, rocks like these are considered intrusive or plutonic igneous rocks. And the size of the crystals actually indicates how these formed. These formed through slow cooling and crystallization of magma at depth in the Earth's crust. The phenocrysts that you'll find here consist of the potassium feldspars, those that include orthoclase and microcline. Here's one of those phenocrysts right here. Look how big that crystal is. That crystal's over an inch in size, and these are known to get close to 2 inches in size. It's huge. Now, this all happened a really long time ago. How old is this stuff? Well, it's well over 1 billion years old. How do we know this? Well, through the processes of radiometric dating. We can date things like the zircons and biotite minerals in the granite to figure out an approximate range of how old it is. This process works by comparing 2 isotopes in the mineral biotite, in this case. They compared rubidium-87, which is an unstable isotope and decays into strontium-87 over time. By knowing the half-life of such minerals, they can estimate how much of the parent mineral, the original one that was there, decayed into the daughter mineral, the strontium-87. And then they can estimate how old this stuff is. What they found was that the dates looked to be 1.45 billion years old. This stuff is pretty old. It's not as old as the Earth, but still pretty old for a rock unit like this. Aside from those huge pinkish feldspar crystals, this granite also consists of some other minerals, such as the lighter feldspars like plagioclase, and it also consists of some darker minerals, such as biotite and magnetite. That mineral consistency gives it kind of a mottled, pinkish grayish look with those specks of darker minerals contained. In some areas, you'll find it as a pegmatite granite. It's also often intruded by aplite dikes and andesite porphyry. With this consistency, it could easily be classified as a quartz monzonite. Monzonites are considered to be porphyritic with really large feldspar crystals that are well formed and are generally darker granites, like this one. And when the quartz content is greater than 10%, it's called a quartz monzonite. It's typically overlain by an unconformity and then conglomeratic members of the Apache group. And where we don't find Oracle Granite, the Apache group sits atop the penal schist. A similar geologic stratigraphy can be found among mountains in southern Arizona, such as the Whetstones and the Santa Catalinas. And that's the Oracle Granite. Thanks for joining me again for another featured formation. If you guys are curious about other formations I've covered, just head over to the formations playlist and you can see all of them.
And topography, guys. So now we have a rock. All right, guys. Classic red bed.